On July 1st, 2025, a single pixel of light changed everything we thought we knew about our cosmic neighborhood, racing toward us at 130,000 miles per hour, fast enough to cross the United States in under 3 minutes. Something ancient had arrived. Something that had been traveling through the void between stars for potentially billions of years. But here's what keeps astronomers awake at night. What if everything we think we know about this visitor is wrong? Tonight, we follow the trail of 3I/Atlas, the third confirmed interstellar object ever detected. A cosmic messenger carrying secrets from the deep history of our galaxy. Secrets that might challenge everything we believe about intelligence, purpose, and our place in a universe far stranger than we dare imagine. The story begins in the Atacama Desert of Chile, where the ATLAS telescope network maintains its silent vigil against the cosmic dark. On that July morning, automated software flagged a moving object, designation C/2025N1. Within hours, astronomers worldwide realized they weren't looking at just another comet. The mathematics told an impossible story. This object was moving on a hyperbolic trajectory with an orbital eccentricity exceeding 1.0. When Dr. Sarah Chen first saw those numbers, she had to run the calculations 3 times. This thing came from another star system entirely. Unlike the billions of objects bound to our sun in elliptical orbits, 3I/Atlas traces a path that can only mean one thing. It's an interstellar wanderer, the third confirmed visitor from beyond our solar system. But unlike its predecessors, Oumuamua and 2I/Borisov, this ancient traveler carries something unprecedented, questions that push the boundaries between natural phenomenon and something far more unsettling. The initial measurements stagger the imagination. 3I/Atlas moves at over 130,000 miles per hour, nearly twice as fast as any previous interstellar visitor. Its hyperbolic excess velocity of 61 kilometers per second represents the speed it maintains, even accounting for our sun's gravity. This velocity dwarfs its predecessors. Oumuamua traveled at 26 kilometers per second, while 2I/Borisov managed 32. 3I/Atlas moves nearly twice as fast, suggesting either violent ejection from its birth system or something else entirely. As Dr. James Wright notes, the progressive increase in velocity across these 3 visitors is intriguing. It could be coincidence, or it could point to something we haven't considered. Determining its size proves challenging due to the glowing envelope that surrounds it. Current estimates range from 300 meters to 5.6 kilometers in diameter, anywhere from 3 football fields to a small mountain. But here's what's truly remarkable. If 3I/Atlas has been wandering for billions of years, as suggested by its trajectory, it predates our entire solar system. This ancient wanderer carries within its nucleus records of galactic evolution from when the universe was less than half its current age. On August 6th, the James Webb Space Telescope turned its infrared gaze toward 3I/Atlas. What it found challenged everything we thought we knew about comet chemistry. The object's coma was dominated by carbon dioxide, with a CO2 to water ratio of approximately 8:1. This wasn't just unusual, it was unprecedented in comet chemistry. Dr. Maria Santos explains that typical comets follow predictable patterns. Water ice dominates, then carbon monoxide, then carbon dioxide. 3I/Atlas has completely rewritten that script. But here's what makes it even more extraordinary. 3I/Atlas was over 3 astronomical units from the Sun, well beyond Mars, when Webb captured its spectrum. Most comets show little activity at such distances, yet this object produced a detectable, CO2-dominated coma extending hundreds of thousands of kilometers from its nucleus. Several theories attempt to explain this chemical signature. Perhaps 3I/Atlas formed near its natal star's CO2 snowline. Maybe extreme age and cosmic ray processing modified its surface chemistry, or possibly insulating dust mantles developed over geological time prevent water escape while allowing CO2 percolation. Yet each explanation raises more questions. What stellar environment could produce such extreme chemistry? What processes shaped this object during its billion-year journey through space? As observations mounted, a curious absence became as significant as any discovery. Radio telescopes around the world found nothing. No artificial signals, no structured transmissions, no coherent emissions of any kind. This silence aligns perfectly with natural expectations, but it also raises profound questions about our assumptions and our methods of detection. Dr. Elena Vasquez from the SETI Institute points out that the absence of obvious artificial signals doesn't rule out intelligence. It might simply reflect intelligence so advanced that its technology appears indistinguishable from natural phenomena. The search for extraterrestrial intelligence has long grappled with this challenge. If advanced civilizations exist, their technology might operate beyond our current ability to recognize or interpret. What we perceive as natural might be artificially perfect in its mimicry of natural processes. Analysis of 3I/Atlas's motion relative to galactic rotation suggests something extraordinary. This object likely originates from our galaxy's thick disk, an older stellar population from when the Milky Way was young and chaotic. If correct, 3I/Atlas could be older than our entire solar system by billions of years. During its journey through the cosmic dark, our planet experienced the Cambrian explosion, 5 major mass extinctions, the rise and fall of the dinosaurs, and the eventual emergence of human civilization. Yet from this cosmic wanderer's perspective, all of human history represents merely the final microsecond of its multi-billion-year voyage. Dr. Alan Morrison describes it as looking at a time capsule from the deep history of our galaxy. The chemical signatures it carries formed before our sun existed, around stars that lived and died in stellar neighborhoods we can barely imagine. The thick disk interpretation comes from 3I/Atlas's unusual approach angle. While most local objects move with the galaxy's spin, this visitor approaches from a trajectory suggesting membership in an older, more randomly oriented stellar population. But what if this unusual approach angle suggests something else entirely? The question echoes through every astronomical discovery. If the universe should be teeming with intelligent life, where is everybody? 3I/Atlas embodies this cosmic paradox. Each interstellar visitor represents a natural experiment in galactic material distribution. In principle, these wandering ambassadors should eventually reveal signatures of technological civilization, engineered materials, artificial isotope ratios, structured objects that betray intelligent design. Yet so far, all confirmed interstellar visitors appear thoroughly natural. Dr. Frank Drake suggests the silence might be telling us something profound. Perhaps advanced societies prefer what we might call silent emissaries, probes designed to be indistinguishable from natural phenomena. This raises immediate questions. If 3I/Atlas were some form of concealed probe, what observational evidence would ultimately reveal its true nature? Narrowband radio emissions would represent the most obvious technological signature. Unnatural thermal profiles might provide another diagnostic tool. Controlled maneuvers would offer perhaps the most definitive evidence of artificial origin. So far, 3I/Atlas has displayed none of these signatures. Now we cross deliberately into the realm of pure speculation. Everything that follows should be understood as thought experiment rather than scientific conclusion, a mental journey into possibilities that current evidence does not support. The evidence points overwhelmingly toward 3I/Atlas being a natural comet. But science has a history of surprises. Pulsars were first designated LGM, little green men, before revealing themselves as rotating neutron stars. What would constitute convincing evidence for artificial origin? coherent radio emissions indicating onboard electronics, non-gravitational accelerations inconsistent with outgassing, engineered light curves that don't correspond to natural rotation and heating patterns. Professor Avi Loeb from Harvard reminds us that we should remain open to extraordinary possibilities while demanding extraordinary evidence. The scientific method works precisely because it holds all hypotheses to rigorous standards. The most unsettling speculative scenario draws from both serious SETI discourse and our darkest cosmic anxieties. The dark forest hypothesis suggests advanced civilizations might remain deliberately hidden, operating under the assumption that revealing existence invites destruction from even more advanced neighbors. In such a universe, silence becomes survival strategy. Any civilization broadcasting its presence risks annihilation from threats it cannot perceive. If 3I/Atlas represented reconnaissance technology, and we stress this remains pure imagination, the implications would stagger understanding. Such a scenario would suggest our solar system is under surveillance by intelligences capable of engineering objects that survive billion-year journeys while remaining virtually indistinguishable from natural phenomena. The very perfection of its disguise would indicate technological sophistication beyond our current comprehension. Consider the engineering requirements. A probe designed to pass for a comet would need to mimic every aspect of natural behavior. Correct spectroscopic signatures, appropriate outgassing patterns, surface properties that reflect light consistently with natural materials. But perhaps most unsettling would be the temporal implications. If 3I/Atlas had been traveling for billions of years, it might represent technology from a civilization that achieved interstellar capability when our galaxy was radically different. The intelligence that launched it might no longer exist. After exploring the outer boundaries of cosmic possibility, the actual worst-case scenario proves refreshingly mundane. No Hollywood catastrophe awaits. No civilization-ending impact threatens Earth. Those crucial numbers deserve repetition. 3I/Atlas approaches no closer than 1.8 astronomical units to Earth, 270 million kilometers of comfortable buffer. This exceeds twice the Earth-Mars closest approach distance. These aren't rough estimates, but precise orbital calculations accounting for major planetary gravitational influences, relativistic effects, and radiation pressure. When astronomers declare 3I/Atlas poses no threat, they speak with confidence built from centuries of celestial mechanics. Dr. Lindley Johnson from NASA Planetary Defense confirms that the mathematics are crystal clear. This object will pass safely through our solar system and continue into interstellar space exactly as physics predicts. The initially alarming speed actually works in our favor. Objects on hyperbolic trajectories moving at such velocities cannot be captured by solar system gravity. 3I/Atlas moves too fast to linger, performing its cosmic flyby before disappearing back into the interstellar night. The real treasure 3I/Atlas offers lies not in exotic speculation, but in genuine scientific discovery. The object's unusual carbon dioxide composition has already challenged assumptions about comet chemistry, forcing researchers to develop new models for volatile ratios in objects from different stellar environments. The spectroscopic signatures revealed by Webb provide direct evidence for chemical processing around other stars. The high CO2 to water ratio suggests either formation near carbon dioxide snowlines in protoplanetary disks or radiation processing over geological timescales. Either interpretation expands our understanding of planetary formation processes throughout the galaxy. Dr. Heather Knutson from Caltech explains that every chemical signature we detect tells us something about stellar environments we've never directly studied. 3I/Atlas is like receiving a physical sample from another star system. As 3I/Atlas continues its journey outward, fading into the star-scattered darkness from which it came, we're left with more than just scientific data. We have a template for how humanity approaches cosmic mysteries. The institutional response has demonstrated remarkable efficiency. The Atlas survey detected the object. The Minor Planet Center coordinated global tracking. Hubble and Webb provided detailed follow-up observations. Ground-based observatories contributed complementary data, all within weeks of initial discovery. This coordination reflects not just technological capability, but philosophical commitment to shared knowledge and collaborative investigation. The Vera Rubin Observatory team notes that their facility will detect hundreds of interstellar objects over the next decade. Each will teach us something new about our galactic neighborhood. The promise of future discoveries looms large. Statistical studies impossible with our current small sample will reveal population characteristics, chemical diversity, and dynamical properties of the wandering objects that fill interstellar space. Perhaps the most profound gift 3I/Atlas offers humanity lies in demonstrating that patient observation and collaborative investigation can illuminate even the deepest cosmic mysteries. In an era when global challenges seem overwhelming, there's something deeply reassuring about a cosmic visitor that arrives precisely when predicted, behaves exactly as natural laws dictate, and departs safely without disrupting a single terrestrial sunset. The transparency that has characterized this investigation provides hope for how we might handle even more extraordinary discoveries in the future. Should astronomers eventually detect genuinely anomalous objects, the precedent of open data sharing offers our best approach. Dr. Michelle Bannister reminds us that the universe has proven strange enough through natural processes alone. From quantum mechanics to dark energy to cosmic web structure, reality exceeds our imaginations without requiring exotic additions. As 3I/Atlas disappears beyond the reach of our most powerful telescopes, it leaves behind more than scientific papers and data. It has provided a case study in how human civilization approaches the unknown, with instruments rather than weapons, with curiosity rather than fear, with collaboration rather than competition. The silence that follows its departure isn't empty, but expectant, waiting for the next cosmic messenger that will surely arrive, carrying its own chemical signatures from distant stellar neighborhoods, its own challenges to our understanding. In that waiting, in that continued watching of the skies, lies perhaps the most hopeful aspect of our relationship with the cosmos. The conviction that there are always more wonders to discover, more questions to ask, and more reasons to look up at the stars with curiosity rather than fear. Good night, Cosmic Messenger. Thank you for the lessons, the data, and the reminder that the universe remains far stranger and more wonderful than our earthbound imaginations might suggest. Safe travels on your continued journey through the galaxy, carrying whatever chemical secrets and ancient memories remain locked within your nucleus, testimony to stellar environments that existed long before our world knew the warmth of its own star. Until we meet your cousins from other distant systems, other ancient epochs, other corners of the cosmic wilderness that surrounds our small but remarkable planetary home. At the end, do not forget to subscribe to the channel to see our latest uploads. Thanks for watching.